All right, so now that we have looked at the properties of waves and waves in general, we want to look at this in terms of how we can describe the velocity of a wave. So we're going to use some mathematical representations, and we're going to look at how the frequency and the wavelength and the speed of the waves are all related to each other. So when we look at the relationship between the frequency and the velocity and the wavelength of a wave, if you think back to when we talked about velocity the first time, which seems like forever ago, we talked about velocity being how far we travel in a certain amount of time, right? So the distance divided by time is velocity. Now, if we look at a wave, we can look at those particular properties in terms of a wave. So the distance that a wave travels is one wavelength, right? So from crest to crest on a wave, trough to trough. So one complete wave is a wavelength. So that's the distance that we're going to use as our distance traveled of the wave. The time is measured with a period, right? So remember, again, we're looking at the time that it takes for one wave to travel by you. So the time that it takes for one wave to pass by you, that's going to be the period. That's that capital T. So what we've done now is we've made that distance that we've traveled into the wavelength, and we've made the time that we traveled into the period of the wave. So this is one way that we can write this. Now also remember that the frequency of a wave is the inverse of the period, right? Those two things are very closely related. It's how many waves go by you in 1 second. So we can also use that into an equation if we know the frequency. And since the frequency is the inverse of the period, instead of dividing by the frequency, we're going to multiply it. So the velocity of a wave can either be found by taking the wavelength divided by the period, or taking the frequency times the wavelength. So if we're sitting on a dock and we count the waves go by, we find that there are 2 successive crests that go by in 1.5 seconds. The waves also appear to be the same length of the dock, which you measure to be 3 meters. What is the velocity of the waves? So if we look at this, we know that the time that it takes for one wave to go by, right, 2 successive crests is one wavelength, is 1.5 seconds. So the period of our wave is 1.5 seconds. And we measured that wave, the 2 crests, to be 3 meters apart. So the wavelength of the wave is 3 meters. Now we have 2 equations that we can choose from here. One has the frequency and the wavelength, and one has the wavelength and the period. Since we know the wavelength and the period, we're going to use that one. So we're going to take that 3 meters, the length of our wave, and we're going to divide it by the time that it takes that wave to go by us. So 3 meters divided by 1.5 seconds is going to give us a velocity of 2 meters per second. Now we can also look at it in terms of a picture. So if we can visualize this a little bit. So here we have a wave train. So a train is just several waves right in a row moving along. How many waves are there in this wave train? Remember, a wave is one complete up and one complete down. So that's a complete wave. So we have 1, 2, 3, 4, and 5. So the waves number that we have is 5 in this wave chain. Now, if we assume this whole thing goes by us in 2 seconds, we want to know what the frequency is. So frequency is the number of waves per second. So we have 5 waves going by us in 2 seconds. So our frequency is going to be 2.5 hertz. We can then find the period of the wave, right? So the period of the wave is the inverse of the frequency. And we just found our frequency to be 2.5. So 1 over 2.5 hertz gives us a time of 0.4 seconds. So one of those waves goes by us in 0.4 seconds. All of them goes by in 2. One of them goes by in 0.4. So now we say that the wavelength is 35 centimeters. What is the velocity of this wave? Now remember, we have 2 ways we can find this. We can use either one because we now know the frequency and the period of the wave. So the velocity can be found by using the frequency times the wavelength, or the wavelength divided by the period. Both of these are going to give us the same answer. So 2.5 times 35 and 35 divided by 0.4 are both going to be 87.5 centimeters per second. Now, another really useful thing to do is to be able to find the wavelength of a certain wave. So if we know that an air horn sounds at a frequency of 220 hertz, if the speed of sound in air is 330 meters per second, what is the wavelength of this sound? So we know that velocity is the frequency times the wavelength. So to solve for wavelength, we can divide by frequency on both sides. So wavelength is going to be the velocity divided by the frequency. And so our velocity is 330 meters per second, and our frequency is 220 hertz. So that's going to give us a wavelength of 1.5 meters. So to solve for wavelength, we're going to rearrange it so that we have the velocity divided by the frequency. So just as a kind of a review of these particular symbols and units, the frequency of a wave is how many waves that go by in 1 second. The symbol is F, and we measure that in hertz. Wavelength is measured in lambda, which is the Greek letter. It looks like an upside down Y. And that is measured in meters. And that is the length of one complete wave. Velocity is still V. Now, when we talk about light, when we talk about the speed of light, a lot of times you will see it written as C. But it's still going to be in meters per second, no matter what we do. And then the period of a wave is the time that it takes for one wave to travel by you. And that is the inverse of the frequency. And it's measured in seconds. And we have a symbol with capital T.